Hello everyone, and welcome to a special episode, I guess I can say, of Math with Audrey. I'm your host, Audrey. So I'm not sure who's going to come on, if anyone's going to come on, but this is a concept that one of my students that I had today was struggling with a little bit. So I figured, you know what, if she's struggling with it, I know someone else is struggling with it, and it's called completing the square. So this happens after you do a little bit of factoring, and you really want to kind of break down concepts a little bit further, but kind of do it in a shortcutish type of way. All right, hello. So we have a couple of examples, but the main thing is happening over here on the side. So we have a couple of formulas that you definitely need to kind of keep an eye on. So I'm going to zoom in so you guys can do a little screenshot. So when you're completing the square, it's a little bit different, especially to start when you are factoring a quadrilateral. So anything with the highest degree to the second power. Just like this little example, my highest degree is to the second power. Now, normally when you see a quadratic, you need for the equation to equal to 0. But when you're completing the square, it's the complete opposite. You want your equation to equal to the original c if it was in standard form. And I'm going to show you by example what I mean by that. But then we're going to replace so we can complete the square. And I'm going to show you. But you need to have this formula memorized, which it should look somewhat familiar. It's b over 2a squared. If you ever did the quadratic formula with that negative b plus or minus the square root of b squared minus 4ac over 2a. Yeah, say that 28 times fast. That is basically what this part is. You're just taking the b, don't have to worry about the negative sign, and then you're taking what was the denominator of that equation, which is my 2a. So when we're doing this, we definitely need to make sure that our equation is not equal to 0, but equal to the constant. So when we're equaling to the constant, we can kind of go right into it. So first thing I want to do is find my new c value. So I'm going to have my formula, my b over 2a. The b is the 14. And then you do 2 times your a. My a is the coefficient in front of p squared, which is 1. So 2 times 1 will give me 2. And then we're going to square our result. So just like PEMDAS, we want to do what's inside the parentheses first. All right? So the b, if you recall, standard form. ax squared plus bx plus c. This is in standard form. Your a value is the number or the coefficient that's in front of the x squared. The b is the number that's in front of your p in this case, which will be 14. And the c is my constant, which originally I have over to the side. Okay, no problem. So now, let's do inside the parenthesis. So 14 divided by 2, that will give us our 7. Now, I'm going to keep it inside of a parenthesis because I'm going to show you what I'm going to do with this 7 later on. It's kind of like a little shortcut. Now, let's square it. So 7 squared, it is not 14. Okay, it's definitely not 14. So it's 7 times itself 2 times. So 7 times 7, that gives me 49. So if you notice my setup, let me see if I can slide this over a little bit. I give you the basic setup. So ax squared plus bx, so that's the original, plus whatever your new c is. So that's the one that we have in pencil. So it's going to look like this. We have our p squared plus 14p, and we're going to add our new c, which is 49. And we're going to equal the 32 plus the 49. Okay, good. Hey, Two Scoops. Almost forgot. You guys keep getting a shade. This is what happens after I finish tutoring. Let's try this. That should make it a little bit better. So now, if you notice, on the left-hand side, we have a perfect trinomial, all right? So when we, and I'm going to do it the long way a couple of times. So when we factor this perfect trinomial, I'm going to have two parentheses. P squared, since my leading coefficient is 1, I can go ahead and split my p's, because p times p gives me my p squared. So now we got this 49. So 49, the square root of 49 is 7. 7 times 7 gives me 49. And since it's a positive 49, and it's a positive 14, because if I add 7p plus 7p, it will give me my 14p. Notice the parentheses. The parentheses are exactly the same. So the other way of stating this will be p plus 7 squared, because inside the parentheses are exactly the same. So that's happening on the left side. Now on the right side, I get to combine 32 and 49. I think that's 81 if I'm not mistaken. Okay. So now I want to basically solve for p. But right now I got p plus 7 inside this parenthesis and it's being squared. It's like, you don't have to subtract that. No, I don't. Because with me adding both the 49 on both sides, I am balancing it out. Yes, it's already balanced out because I did the addition of the new c on both sides. Okay? Hey, Ann. So now we want to get rid of this square. The opposite of a square is a square root. Basically, they cancel each other out. So square and square roots cancel each other out, but it leaves me with p plus 7 equals. So now square root of 81 will give us plus or minus 9. And you're probably like, whoa, 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 where's that plus minus come from, right? So remember, 81, if I had 9 times 9, that will give me 81. As well as negative 9 times negative 9 will also give me 81. Because remember, a negative times a negative gives me a positive. So when you are solving and you're coming out of a radical, you always have to put both the positive and the negative of your solution. Okay? Aw, Angel, why are you giving up on school? But you can type this in the calculator and get the same answer. You will get a decimal. Well, in this case, you'll probably get a whole number, but you're supposed to get two answers. So if you plug into your calculator, would you get two answers? Or are you just going to get one? Yes, and sometimes that does happen. Yep, this is a quadratic, but what we're doing is we're doing it by completing the square. So now we want to solve for p. So I'm going to subtract 7 on both sides. So when I have my p equals, it's going to equal -7 plus or minus 9. So I'm going to get two answers. One of the answers is going to come from -7 plus 9. And another answer is going to come from -7 minus 9. All right. So Shella, we're going to go over in a second. So now we found our p. The two answers that represents p will be a +2 and a -16. So, unlike signs, subtract and take the sign of the bigger number. Yes, unlike signs, you are going to subtract and take the sign of the bigger number. Same signs, you're going to add and keep that sign. Keep the negative sign. All right. So this is what's happening. So you first off, your equation does not equal 0. Normally when you're breaking down a quadratic, it equals 0. But if you're doing it by completing the square, it has to equal your constant, which it does, which is at 32. So then I need to find the new c to complete right here, to complete my square, hence the name. So once I figure out what my b is over 2 times the a. The a value is a 1, so that's why that's just a 2. And my b value is the 14. It's one that's next to just the variable, just a single variable, not squared in its single linear form. So we have 14 divided by 2 gives me 7. Now here's that little trick that I wanted to talk about. This 7 inside the parenthesis, did you notice that that +7 also showed up down here? So whatever you get inside this parenthesis, you could, and it'd be nice to set it all up, but you can skip that to come straight here. So it'd be p plus 7 because inside this we got a result of a +7. But when we square it, we need to add our answer, which was 49 on both sides, so we can complete the square, which I highlighted for you. So if you ask, is this always going to be exactly the same? Yes. That's why you're completing the square to make it into a perfect trinomial. No, this is completing the square. This is in vertex form. Okay, this is completing the square. So, taking a look, we're doing all this to eventually figure out what are our two solutions that will make our original into a true statement. All right, so I know, and it does. It takes a lot of steps, but at the same time, hopefully, I'm going to try to break it down step by step. Okay, So, going to start again with the next problem. So we have v squared minus 6v equals 55. And anytime they say do this by or factor it by completing the square, it always has to equal your constant. So with that being said, it does equal our constant. Yay. So I can say my ax squared plus my bx, okay, it's going to equal my c. So this is the standard form for completing the square. So my a value is in front of that v squared. If you don't see anything, it's a 1. The b value is always what's in front of the linear variable, okay, which is going to be a -6. So from here, let me kind of write the formula out. It's going to be our b over our 2a, and it's being squared. So now let's substitute. Our b is -6. Our a is 1. So 2 times 1 will give me 2. And we're going to square it. So just like PEMDAS, we always look what's inside the parenthesis first. So -6 divided by 2 gives me what? And I don't mean to insult your intelligence. I just want to make sure that you guys are with me. Okay, so -6 divided by 2. Okay, hey Tesh. There you go. So we got -3, we got -3. Usually one more will make it solidified. I like to do things in threes. So, -6 divided by 2 gives me -3. But TG told us what our final for this is going to be. -3 squared is the same as saying -3 times -3, which does give me my 9. Good. All right. So this is what we're going to use to complete the square. So let's rewrite. So we have our v squared minus 6v. And we're going to add our answers. So that'll be plus 9 here. Bring down my equals 55. And we're going to add 9 here. Okay. So I'm going to show you all the way through. So on the left-hand side, we have a perfect trinomial set up. So that means I'm going to split up for my 2 factors. Since my leading coefficient is 1, I can split the v's. Insert jokes here. Then, like I said, this number right here in the parenthesis is what you're going to put down here. And it was a -3 before we squared it. So -3 goes here, -3 goes there. And if you want to check it, -3 times -3 gives me a positive 9. And -3 minus 3 gives me that -6. So it works. And since we have the same information, the same products, we just make it into one parenthesis and we square it. The square is to represent the 2 products that we have. Yes, Barney, we're going to be solving for v. But what is this v minus 3 squared going to equal? What's it going to equal? Yes, but we're solving it right now, Barney, using completing the square. Okay. Okay, so we got 64, 64, 64. Yes. So this is going to equal 64. Okay. So now, because we could do that way, Barney, but if we're doing completing the square, I don't know, it's always, there's multiple ways of getting the same answer. Now, here's my thing. If they ever just give you and they say factor it and solve for the solutions, go. Do whatever ones you want, all right? Now, what is next? We got FTC, square root. So we're not just square rooting the 64, but we're also square rooting both sides because we want to get rid of that square. The opposite of the square is the square root. So they cancel out. So this will leave me with v minus 3 equals what? Equals what? Okay. So Jasmine, Barney, there's something missing. What's missing with this 8? What's missing? Hey, Carla. There we go. Yes, good. We have to add the plus minus. So it's not just positive 8, it's also negative 8. Okay? So anytime we're breaking down a radical and we're turning it into a whole number, unless it's like real world sich, we always represent the positive and the negative. So now, I think, I don't know what that picture is, says add 3. I don't know what it is. Okay, so we're going to add 3 on both sides. So that means negative 3 plus 3, they cancel out. Let me bring my V down. Enter all the jokes. All right, so now we have this positive 3 plus minus 8. Don't just add the 3 to the 8 because we're supposed to get 2 solutions. How do I know? Because my highest degree is to the second power. That's telling me how many possible solutions I should have. Okay. Okay, the picture is Spider-Man. All right, thank you. Because from here, yeah. Yes, there you go. Now, you have 2 solutions. One of those solutions is 3 plus 8. And the other solution is 3 minus 8. So what would V equal? Okay, not a problem. Yeah, I had a student today that was really struggling with this. Okay, so Barney's saying 5 and negative 11. Do we agree? All right, so Jasmine says 11 and negative 5. Do we agree? Oh, it's a battle. Fight to the death. Okay. No, Barney, you were close. The only thing was your signs. Okay, that was the only thing that was different. So don't give up. Okay, we're not all perfect. I know sure as hell I'm not. All right. So 3 plus 8 gives me that 11. And 3 minus 8. So if I have $3 and I'm trying to spend $8, that means I am short $5. So those are the 2 solutions that's going to make our original equation into a true statement? Oh, of course. Don't worry, I got a whole stack of them. I think it's like 11 problems, but I don't think I'm going to be doing all 11. But I'm going to switch a couple of things up. All right. Okay. Why? Why? Why not? Why? C. Jones, what we got? Why what? Like, why am I doing this? Why do I exist? I don't know. God woke me up. I don't know what he wants. All right. So, if you want the steps, let me unzoom just a hair. I'm going to do another one, but if you want to screenshot the steps, okay, this is basically what you guys are doing. First, you need to set your equation to equal the constant. Then you're going to find the new C value, okay, by completing the square on both sides. Then use the number inside the parenthesis to complete the square. That's that shortcut that I was talking about. And then add that solution, what we got from the C, on both sides. So then you're going to solve it by using the square root method, which basically means cancel out the square with the square root. All right. And don't forget about the plus minus. Is to bring the number to the other side with the variable so the equation is equal. Yes, you can do that. 0, then you factor and solve. Yes. So if you have it equal 0 and you factor and solve, you're not doing completing the square. You're just factoring the quadratics. Remember, there's so many different ways. First, you can factor by GCF. You can factor by grouping. You can just factor what you were doing with the trinomials. You can do the quadratic formula, that's 4, or you can complete the square. So there's 5 different ways of factoring, and you'll get the same answer. Okay? So if they ever correct and say you have to do it this way, what is the first step if you were doing, completing the square, or what would the setup look like? Then you will have to figure out, okay? So I'm not saying you're wrong, but for right now, as we're doing completing the square, the process is going to be different. You don't have it set equal to 0. Any other way, you have to set it equal to 0. But completing the square, it has to equal the constant, okay? Okay. All right, so let me slide this over. And let me get my pen situated. All right, so if we have x squared, can y'all see that? Okay. So x squared minus 12x plus 11 equals 0. Now, if they said just go ahead and straight factor this, we can. But they want us to do by completing the square. That was the instruction. If you think I'm lying, here's my little paper that I'm using. And it says, solve by completing the square. All right. So my very first step is this cannot equal 0. Okay. I'm going to have to subtract 11 on both sides. Because it can't equal 0, it has to equal the constant. So now I'll have x squared minus 12x is equal to negative 11. Next step, will be to find the new c. And we're going to use that formula, b over 2a, and we're going to square it. Okay. Yeah, not a problem. Okay. Yeah, that's true. Yes, we definitely have some teachers that will do that. But I know sometimes there'll be people here that are just trying to get, like, say, their GED, or they're just trying to get the ASVAB, or the ACCUPLACER. And sometimes they just need to learn a couple new little tricks and sticks in order for us to get it. All right. So yes, our B, very close. Our B is a negative 12. We gotta make sure we get the sign. Over 2 times our A is 1, so that means we're gonna have A2, and then we're gonna square it. So just like PEMDAS, we do what's inside the parenthesis. So negative 12 divided by 2 gives me a negative 6. And then, what's negative 6 squared? This is like second semester Algebra 1. Okay, good. Positive 36. Love that. Okay, good. So make sure 81 Cruz. Make sure 81 Cruz. Think so. All right, make sure it's a negative 6 times negative 6. A negative times a negative gives me a positive, and 6 times 6 gives me 36. So now we're going to rewrite the beginning of our equation. So we have x squared minus 12x. And then we're going to add the c that we just found, plus 36 equals our negative 11 and plus 36. Okay. So hopefully the color changes is helping a little bit, so you can see where things are coming from. Okay, so the 36 is the c value that we just found. So we can make this left-hand side into a perfect trinomial. So if I were to make it into a squared, what would go inside of this parenthesis? If you could take a guess, what do you think will go inside the parenthesis? And if you're not sure, question marks are definitely yes. Good. Okay. Close. Close, Spider-Man. Mr. B. Mr. B. I think you're the Mr. B that I know of. It's been a minute, if it is. Okay. Yes, J of spades. There we go. So, we're taking our variable, which is x, and we're taking the number that was found inside of that parenthesis before we squared it. Our minus 6. Okay. You could, because take a look, negative 6 times negative 6 gives me a positive 36. And negative 6 plus negative 6 gives me a negative 12. So this works out for us. Okay? So we're always going to keep the signage before. And this is going to equal negative 11 plus 36. What do we get for an answer there? What's going on the other side of the equal sign? We got 25, we got 25. Hello, Melissa. 25, 77. Yes, Mr. B, yes. So we have 25. Okay, so from here, we need to solve for x. So what should we do next? Hello, Lisa. So glad you're able to come on. I actually had a free moment. I was like, and I'm just going to come on because I will not be here at 5:30 tomorrow. Unfortunately, my person switched. Yes, good. Excellent. So we're going to square root because the opposite of a square is not a circle. It is a square root. Oh, bless it. All right. So the square and the square root cancels out, and it leaves me with my x minus 6 equals, what does it equal? What would it equal? Yes, there we go. I got you guys in my mix. Yes, anytime we're coming out of a square root, we should be thinking plus minus. And since 25 is a perfect square root, we got our 5. Because 5 times 5 gives me 25, and negative 5 times negative 5 also gives me 25. So that's why we have two values. Hey, Pong. How are you? All right. So now we're trying to solve for x. So that means we're actually going to add 6 on both sides. So negative 6 plus 6, that cancels out. So then we have our x equals. Now, don't just add the 6 to the 5, okay? Remember, this is actually representing two numbers. So that means the 6 that we just found, that's going to be on the outside. And then what comes down is our plus minus 5. So we're going to have two solutions. One solution is going to deal with 6 plus 5, and the other one's going to deal with 6 minus 5. So, what is my final answer? What is x representing? So I have a positive 11 and 1. I have 11 or negative 1. I have a 1. Versus unfoiling. Well, it's part of the list of the factoring. It's part of the list of the factoring. Positive 1 is correct. Okay. So 11 and 1. 1 comma 1. 1, 1. Hello, Miss B. Okay, 11 and 1. Good. So 6 plus 5 gave us our 11. And 6 minus 5 gave us our 1. If you want to put them in numerical order or into two separate x values, you can do that. Right. So negative 1 is the answer. No. So we will get like a positive 1. When plugged. So like if I plug in, I'm plugging, we can even do the original if you want. If I plug in a negative 1, negative 1 squared will give me 1. But negative 12 times negative 1 will give me a positive 12. So that means you got 1 plus 12, which gives you 13. And 13 plus 11 is definitely not 0. Okay? So if we do with a positive 1, this will give us our 1. Negative 12 times 1 will give us negative 12. So 1 minus 12 will give me negative 11. And negative 11 plus 11 will give us 0. So it definitely has to be a positive 1. If I'm doing polynomials and foils now, when will I do this? You will do that later. So after you do your factoring of trinomials, that will be coming along the pike. And usually what follows after this is you're starting to talk about radicals. And then you're going to be talking about negative radicals. You can just factor mental math, no reason to complete the square. Right. So here's my thing. The reason why I'm showing completing the square, because some assessments do, and they say for you to do completing the square. So that's why. I don't want people to miss out on points, because I know I could have easily factored this out. I could have just split it up with negative 1. I could have had like x minus 11 and x minus 1 equals 0. I could set them both equal to 0 and be done. I know this. You think I'm like all this stuff? No. But here's my thing. When other people and other professors are saying do it by this way, I'd rather have people say, you know what, I know how to do it, let me break it down, versus what the hell is that, right? So that's why I kind of show it both ways. Okay. Why are you still solving it? It's been 15 minutes. I know, because I take my time. What grade level is this math? Second semester, Algebra 1. It's mostly Algebra 1. Yep, second semester, Algebra 1. Oh, give up school because of math. Oh, don't let math stop you from what you want to do. Okay, does everybody know that this is second semester Algebra 1? Okay. Everyone keeps asking the same. Why aren't you using the quadratic equation? Okay. I'll let everybody ask the same question over and over again. Ready? I'll give it all out. Why not just factor? Okay, go ahead. Keep asking the same questions. Ready? Yes. Okay. So, again, and if you're here and if you want to tap while I explain, you can tap while I explain. So, there are multiple ways of factoring. Yes, you factor with the GCF. You factor by grouping. You factoring trinomials regardless if the A is 1 or not 1. Okay, you're also doing the quadratic formula, and then you also have what's called completing the square. Now, there are some professors and there are some teachers that do not give you the choice. They say, we want you to solve it by either GCF or solving it by grouping or solving it by the trinomials and then completing the square or quadratic formula. So because there are some people that do not have the choice, and one of my students was struggling at this morning, I figured that she's not the only one. So that's the reason why I'm on here showing completing the square. Now, do I know that, sweet angels, I know it takes freaking forever. Don't you think I sat here and I did 3 problems? I started this live at 8:30. It is 9:16. So I was like, and you can give all this stuff, right? Would give us all permission to scream if we missed the GCF and the problem. Okay, well, that teacher is heavily medicated, but sure. What circumstances can you not use factoring in completing the square? Well, if you're not dealing with quadratics, that will be it. You're dealing with just linear functions. Yeah. Is universal. Yeah, it is. And quadratic formula is universal. Awesome. I get when we're working on the method, but when it's easy trust me, Sir Isaac, trust me. I understand when it's easier, but then all of a sudden, here comes that one teacher down the pike. You know who I'm talking about. That one teacher that really wants to show off his skills or her skills, and then they want the kids to say, I want you to put everything in a fraction. I don't want you to give me the decimal. Or why do you have to give me the decimal? Well, the instruction said the decimal, but I want the fractions because, hey guys, I invented math. Does that sound familiar? Does that sound familiar? Because I know for sure I had some teachers that actually wrote the freaking textbook. And I'm like, do I have a chance in hell here? And if the answer is no, I don't know. And then this is why. This is the main reason why I teach like this. I like to give my students choice. That's me. But I have to show them all the platforms in order to give them choice. There are some kids that loves to do completing the square. Love it. Like that's the nicest way that I could put it on TikTok without getting shut down. Okay? So it just seems like need to be coefficients or do factoring completing. Okay. Right. So when we're doing all that, we got all those lovely little factors. All right? So this is what's happening. All right? You can shoot the messenger. Go ahead. I feel like I'm bulletproof. I got 22 years in the classroom. In the trenches. Right? So, let's move on. I try, like for me, I always have like my students, if they feel like they came up with a way, I love to have my students come up to the board and say, hey, show me your way. And if it's something that I know that's going to work every time, I would actually name the way after the kid. I'm like, hey, you can either do it my way or Dante's way. Knock yourselves out. And it makes them feel empowered. Of course, that's what we're supposed to be doing. But, you got some people that are just here to collect a paycheck, which it cracks me up because it's really not a whole hell of a lot and just taking up space. So, that's what we're doing. But on to the next one. And of course, I'm going to make it just a hair challenging. Just a hair challenging. Are we going to do quadratic formula? No. We're going to stick with completing the square. Because I love to torture you. You probably have 5 stars. Actually, I have 5 stars on Google. So I have over 60 reviews right now. Yeah, I used to be a classroom teacher, and just literally 2 weeks before they closed the schools down, I told my principal I wasn't going to come back because I got tired of the foolishness. I got tired about the meetings, about the emails about the meetings. It doesn't really freaking matter, All I cared about was, are my kids okay? I was Mama Bear. And trust me, I fought for those kids every blessed day. Every blessed day. Well, we're going to try a new method this week. Then 2 weeks later, we're not doing that anymore. It's ridiculous. All right. Well, thank you. All right. So this is kind of funky. All right. This time we need to get our x's on one side and our constant on the other. Now, we can approach it one of many ways. We could either subtract the 4x squared, or, because no matter what, we're still going to have to get rid of the 4s and stuff like that. Actually, I don't like this one, but I'll try it. We'll try it. Actually, you know what? Have you guys ever done the AC method? Put it in the chat, yes or no. I feel like being really rebellious. Why not? I'm 52. I can do whatever I want. The world could suck it. All right. Thank you, Isaac. Aw, thank you. Okay, I got a yes, I got a no. Anyone else heard of the AC method? Like, I'm not naming it after me because that is my initials. But have you heard of the AC method? Have you heard of the Muffin Man? The Muffin Man? The Muffin Man! I do, but rusty? Okay. All right. Let me introduce you a little bit to the AC method. Now, AC method is not completing the square. So that means my equation has to equal 0. So I need to move everything on one side. The easiest way for me to do that, let's be real, let's subtract 6x on both sides. And I'm sorry, but my cat just scared the living hell out of me. She's just sitting there staring at me. And in order for me not to get a glare from the camera, I'm basically in a dark room and the only light that I have is my, whatever, this ring light. And then always just look and you see these white eyes just staring you down into your soul like, dude, what do you want? Like I owe you money or something. All right, so we have 0 equals 4x minus 6x minus 1. Okay, so when I subtract the 6x on both sides, I just rearrange it so it can be in standard form, meaning you're starting with your highest degree, then your next one down, then your constant. So to do the AC method, remember, your A is always the coefficient in front of the x squared, your B is in front of the x, and your C is your constant. So in this case, my A is 4, my B is -6, and my C is -1. Okay, I'm going to pause right there to see how you guys are doing. Is a 16. We're going to add 1 on both sides. Okay. All right, so are we okay so far? So all I did, the easiest way for me was to subtract the 6x. So I have 0 equals 4x squared minus 6x minus 1. I just put it in standard form. So then from here, I'm just writing out what's my A, what's my B, what's my C. Okay, are we okay? Give me a thumbs up, a Y for yes, an emoji. Telling me how you feeling. Okay, there we go. Thumbs up. Thank you. Okay, what is happening? Well, we are doing factoring, and I'm not sure if you have seen factoring in 7th grade just yet. If you're in Algebra 1, it's coming. If you're not in Algebra 1, just sit back, relax, and enjoy the ride. All right. Awesome. So now, here's the next piece. I'm going to draw a cross or an X. What I'm going to do is I want to multiply my value of A and C and put that answer in that space. So A is 4, C is -1. 4 times -1 is -4. And I'm going to put that -4 right in that spot. Okay. That's fine. So now I'm going to write the B. And I'm just going to rewrite the B in this spot. And my B is a -6. So this is when it gets funky. Oh, okay. That's all right, Boomer. It's like, we're just talking about triangle prisms and rectangles. I'm like, okay, it's coming. Don't worry. All right, so now, here's the thing. Think about this. Is there two numbers multiplied to give me a -4 and added to give me a -6? Matt's like, no. I was like, is there? Nope. Don't even breathe, nothing. Just get right to it. Okay? So two numbers multiplied to give me a -4 and add together to give me a -6. Okay? So you're saying we gotta use the quadratic formula? Huh? Do we? Do we now? Because that's what my girl Tash. This is X Games. Yes. It's almost like it. Okay? So, if you're not sure, because we already had one person that said no, no one else. So we got Carson. Carson! All right? So, if I take a look, multiples of 4 is 1 and 4, 2 and 2. All right? Hold on. Here comes the TikTok slide. I feel like it's a dance every time. Slide to the left. Slide to the right. Crisscross. Crisscross. Okay. Cha-cha, do the slow. All right? So, all we saw was 1 and 4 and 2 and 2. Either way, it's not going to give us a -6. So, it looks like we're going to have to go with the good old quadratic formula. Just like all this moving around, which is my -b plus or minus the square root of b squared minus 4ac all over 2a. There's a song, but I don't know it. I don't do songs in my classrooms. I'm not one of those singing type people. No. Okay. We did this for math too. I'm a freshman. We did it like a month ago. Yes. Yes. So you should be in like an Algebra 2 right now. Yep. Is it -3 and 13 square roots? Okay. They don't add the -2, the -6. No. Because if I look at factors of -4, that'll be like 4 times a -1. 4 plus -1 gives me a 3, not a -6. If I wanted to say -2 times 2, that gives me -4, but -2 plus 2 gives me 0, not -6. Okay? So you won't be able, even if you flip the negative around and made this a -4 plus 1, times 1, that will give me a -3. Still nowhere near 6. So this is why we're going to use our ABC to fill in the quadratic formula. So we have negative. This is the part that screws everybody up. You're plugging in the -6 for the b. In the original equation, it comes with a negative. Okay? So you're substituting the -6 just for the b. Bring my plus and minus, square root, my b, which is -6 squared, minus 4 times my a, which is 4, and my c, which is -1. Let me see if I'm still on screen. Okay, you guys can still see. And all of this loveliness is over 2 times my a, which is 4. I might be able to squeeze a little factoring in. I'll try to put it on the other side, since everyone is so over completing the square. Okay, so now we got our x. We have our negative times a -6 is a +6, plus or minus. Okay, -6 squared. We talked about that a couple times tonight, which gives me a +36. Now, -4 times 4 times -1. Negative and negative gives me a positive. 4 times 4 gives me 16, and 16 times 1 gives me 16. Over 2 times 4, which gives me 8. Okay, let me pause for a second. How are we doing? All right. I love how I was like, looks pretty. All right. So now we got to do what's underneath our radical. So we have our 32 plus our 16. So that gives me a lovely 48. So we have x equals 6 plus or minus the square root of 48 over 8. Now, square root of 48, that's not a perfect square root, but it could be factored. We need something that's going to give me a perfect prime combination. All right? Ooh, you're right. You are so right. 52. What am I smoking? Not because I've been doing math all day. Okay, so let's try this. 52. Now, 52, I want to know if I got a perfect prime combination for this. So if I come to 52, so my 52s, I have 1 and 52, I have 2 and 26, and I have 4 and 13. Which do you think will be a perfect prime combination that we should use? So Jasmine... No, you're not sorry. What are you saying sorry? No, you're right. I screwed up. What are you saying sorry for? Yes. So the 4 and 13, okay? Because 4 is perfect and 13 is prime. So we can break this down, and I'm going to break it down. Where can I break it down? I'm going to break it down over here. So we got our 52, and we said it's going to be square root of 4 and square root of 13. Square root of 4 gives me a whole number of 2. Square root of 13, since that's prime, I just keep it. So if I can't break it down, I bring it down. So we got 6 plus or minus 2 square root of 13 over 8. Now someone says, can we just cross out the 6 and the 8? Now, in order for us to simplify all 3 spots, 1, 2, 3. Okay? All 3 of these spots have to have something in common in order for you to reduce. So let's just say, just playing around, that this was just basically the square root of 13. That means I cannot simplify the 6 and the 8. all three spots have to have something in common in order for me to reduce. And yes, TG, it is 2. So 2 divided by 2 gives me 1. 8 divided by 2 gives me 4. And 6 divided by 2 gives me 3. So I'm going to write my final answer in this little space over here, which is x is equal to 3 plus or minus the square root of 13 over 4. I could put the 1 in front of that radical, but it's understood to be there because there's 1 square root of 13 there. This is my final answer, and it's 2 numbers because of the plus minus. Yes, give me one moment and I'll unzoom. Yep, there you go, Danny. Good. Board. Okay. What's the purpose of simplifying your answer to see or like plug in? Yeah, just to make it smaller. That's what it simplifies. Okay. What is the square root used for again? What do you mean? Challenged your brain. Okay, let me unzoom so you guys can take a pic. Let me know, because there's a lot of stuff on my screen right now. So let me know if I need to raise up a little bit. Right. So because the square root of 52, we're trying to get it out of a squared situation, and we're trying to basically simplify it. Now, the only way we can do it is do the inverse of a square, which is not a circle, it's using square roots. Okay, so we're trying to get into a perfect prime combination. Let me push up a little bit. Okay, so we're trying to get it in that perfect prime combination. So see if we can get a perfect radical out and then leaving the prime number behind. Okay. So, all right. Okay, can you simplify before when it's 6 plus minus? No, I would do all your simplification at the end. Yeah, do all your simplification at the end, because you want to get to as close to the true value as much as possible. You use this in real life? That's an awesome question. And this is the response I always give all my students. 1, I don't know what you're going to do or what your definition of real life is, because everyone has different requests, has different dreams. If you're thinking about being an engineer, if you're thinking about, going into anything technical, hey, you will be using it. But I know some of this stuff is obsolete. Ready? This is the truth. Because a lot of things have been replaced by either this or what I'm using as a camera, my phone. I shouldn't even call it a phone because it's really a mini computer. And a lot of those calculations and summarizations is already done. And I'm going to tell you the truth. If you are thinking about being engineering, I already got a couple people that I'm tutoring right now that are engineers, and they're trying to go into the military and they're trying to pass the ASVAB. And the ASVAB has this stuff in it, but they're engineers. They're not using any of this stuff because it's all replaced by your phone. It's all replaced by all the platforms and all of the bips and bops and everything in between. So when are you going to use it in real life? I have no idea. I don't know when you're going to use it. I don't know if it's still obsolete. Hell, look at our classrooms. Our classrooms are the same back in the 1940s and 50s. Everything's exactly the same, right? So hopefully they're going to be humbles you. Yeah. Oh, it does. Because they talk about something. Yeah. And that's exactly what they're doing it for the cybersecurity. And they have to do a lot of just passing. The part that he wants to pass in particular, he just needs to get a score of a 62. And I told him, like, look, if you just get hit hard on these sections, do it. And a lot of it is just plug and chug. But a lot of it is learning how to read the question, especially the word problems. What exactly are you looking for? Because there may be some stuff that you don't have to calculate for. So that's my soapbox. Right? So it's almost like, when are you going to like, trust me, high school math is harder than any other concept. You go to college and you will have teachers that are like, yeah, I would never teach high school math again because it is way too technical. Here's the Excel sheet. Put it into the Excel program. Put it into your calculator this way. Have it saved in your calculator. Have it saved in your computer. That's what a lot of college professors do. A lot of the plugging in, plug and chug. They are not doing step-by-step calculations. But we have some of our assessments, the ASVAB, the ACCUPLACER, the GED, that are still requiring people to break down or at least have an idea what they're looking for. So when you can do process elimination to cancel out the answers so you can get your correct answer. So, hey, I get it, because I used to suck at math. I used to be horrible. I'm telling you, word problems, no. Fractions, oh, hell no. I'm not doing that. And I swear, it was like a battle each and every time. But now, I don't even know how I became a math teacher. Here we are. 22 years later, it's all kinds of crazy. But guess what? Everyone still has to learn it this way. So I can basically tell you the truth, and especially if you're taking any community college classes, I'm going to tell you, it's heartbreaking for people when they're going back to school. Like if you just graduate from high school, maybe a year, 2 years, be able to go back and you'll be all right. But if you haven't been back to school since you were a fetus, like it's hard, because now you're learning concepts that you probably didn't have a teacher that took the time to break concepts down to you when you were in high school. And now you're going back to college and you're learning a whole year or maybe like a half of Algebra 1, a half a year Algebra 1 in 7 weeks. The hell? How are you going to do that? It's ridiculous. And you're stressing out. You're comparing yourselves with other people in the classroom. There are some kids in the classroom that just graduated from high school. You haven't been in high school or even thought about high school in like 20 plus years. And then you're sitting there like, I have no idea what's going on and things are going way too fast and I don't want to raise my hand to look stupid. So, feeling my pain, and I'm just pouring my heart out. But it is. And I'm telling you, there are some amazing professors in the community college level, and I will agree with you. But there are some that you cannot understand. They're looking at you. They're saying, okay, well, you need to go to the student union to get a tutor. And then you get a tutor that's like, oh, you're having problems with this? Are you stupid? And then does that encourage you to go back to the student union? Hell no, it doesn't. So no matter what, it's not just the math. It's a lot of factors that play into it. And to be honest with you, there's a couple reasons why I'm here. The reasons why I'm here and I go live on TikTok is because I want to break a cycle. I know there's a lot of parents that did not have a good experience with math when they were younger, were probably told that they were dumb, not have anyone to support them, and now, not purposely, but now they're pouring their mathematical insecurities onto their kids, and their kids are raising every excuse in the book like, oh, I'm not going to be good at math because my mom wasn't good at math. My dad wasn't good at math. My grandpa, like they're going back generations. They're going back to their ancestors. Yeah, we weren't good at math. No, it's because one person had a bad experience and they poured that bad experience onto their kids. So now I'm sitting here saying you can. Because my mom was like, math is not my thing. Go to your father. And we were okay until algebra kicked in. Yeah. And I was basically on my own. And it just took many years. Finally, I'm working as a special educator. And all of a sudden, it took one teacher just to say that fractions is nothing but division. And I was at the rightful age of 25. And all of a sudden, math started making sense to me. Right? Generational trauma, right? Yeah. Better. Oh, yeah. Visit the math lab. And all of a sudden, you got someone, you're coming in at a 52-year-old. You got someone that's freaking like 20, and he's sitting there talking to you like you're a child. I don't know. Just drives me nuts. Just drives me nuts. So anyway, yes. So it is very challenging. And I like to come here to just break concepts down step by step. If you're learning, awesome. I want you to learn and to show you that you can do math. You can do this. And I know some people, they're like, okay, there was tons of people in here and they're like, yeah, oh, it's math. I'm out of here. Or, oh, this lady is going way too slow. She's way too easy. And I'm like, all right, you could go somewhere else. Like there's tons of people. There's tons of people that are always breaking down math concepts. So, oh, sorry, I forgot to put factoring. Because someone did ask me about factoring. So we're just going to do some regular old factoring. Get ourselves all nice and sweet. Right? They knew your name. Yeah, I remember going to a math lab. There was a guy named Greg. And of course, for me, I was a student athlete. So a lot of the teachers just looked upon me in shame. I don't know why. Because they're like, oh, student athletes get everything and we don't get anything. And I'm like, dude, go ahead and come and join me at the butt crack of dawn as I'm running sprints, setting screens, basically beating other people's children up on the basketball court for 3 hours, then taking a quick shower to hurry up. Can't go to the cafeteria because it's closed. And then you go to, sit in the class and have a teacher sitting here just talking to you as if you're a little child. So yeah, college was not a great experience. The only thing that saved me was basketball. But, that's what I got to do. All right, so we could do that. But here's the other thing. We can also factor. Since we're just factoring, we're going to set this equal to 0. Okay, so when we do that, we got x squared minus 7x minus 18 equals 0. Since my leading coefficient, which is 1, I can go ahead and split my x's. So I got an x here and an x there, because x times x gives me x squared. So now I need to think, what two numbers multiplied will give me negative 18 and add to give me negative 7? Okay. So we got negative 9 and 2. Do we agree? Negative 9 and 2. Bella's got that. Negative 9 and positive 2. So negative 9 times 2 gives me negative 18. Negative 9 plus 2 gives me negative 7. Awesome. So that means in one parenthesis, I got a negative 9. And another parenthesis, I got a positive 2. So it's a plus 2. This is factored. But since it's equal to 0, that means we're solving for x. And we're going to set each of those parentheses equal to 0. Okay, so we have x minus 9 is equal to 0, and x plus 2 is equal to 0. So now let's solve. Okay, yep, you can do the quadratic formula as well. So you have your x is equal to 9, as well as x is equal to negative 2. All right. Yep, TG 9 and negative 2. Awesome. All right. So as I keep mentioning, and I swear, I love you, but I hate repeating myself, but you know, I gotta suck it up. Used to do it in the classroom, right? That there are multiple ways of getting the same answer. If it's a test question, they just say factor, you pick whatever your happy little heart wants to do. Okay? If you want to do the quadratic formula, do it. If you want to do it by factoring, do it. But as long as you understand what that factoring looks like, or what does grouping look like, because sometimes the formula will be already set up as a grouping problem, and all you have to do is just do the next step. And then boom, you're done. So sometimes it's like you really just gotta stop and take a look at what they're happening. Oh, hey, Hunter. I struggle with mixed word problems in algebra. How many liters of 40% and 60% alcohol is needed? Yeah. Yeah, the whole conversion. Well, there's also how many liters of 40% and 60% are needed to make 10 liters. Okay. Are needed to make 10 liters of 50%. Yeah. You're doing that whole conversion thing. In my mindset, I'm going to be truthful, I don't have it in my mindset tonight. I'm just happy that I was able to get some factoring out of my system. No, I'm not even going to lie to you, Hunter. I'm not even going to lie to you. All right? All right? Yes. Sea breeze. Quadratic equations. Yes, sir, ma'am. All right? All right? So, this whole extravaganza, all right, it all started with the completing the square, which everyone loved. Being sarcastic. Everyone loved it. Everyone loved the completing the square. All right, so it all hones in on this lovely formula, which we had to find our C. We had to do some isolation. If anything, if you want to just take a screenshot of that, you can take a screenshot of that. Then, oops. All right. So then if I unzoomed, we did a couple of examples. Okay, comment on here. Yes, and I loved how everyone was like, oh my God, Audrey, this is the quickest way of doing it. The sarcasm. She's like, we're still doing the same problem. Why are you doing it this way? I know. But these are basically the formats of it. Gives you some examples. Okay, making sure it's in standard form. When you do completing the square, it does not equal 0. That's the only format that for quadratics that your equation does not equal 0. So once you kind of have all that, you find your new C, you add it to both sides of the equation, you find out what your perfect trinomial is turn it into a binomial. Then you do your solving with that square root method, and then you figure out what your two answers are. The reason why I know there's two answers, because in the very beginning, my highest exponent was a square. Okay, that tells you your highest exponent will tell you how many solutions you should have. So if you ever have a cubic, you should have 3 solutions. All right. If you ever have a quartic, yes, believe it or not, there's something called a quartic. Okay, you should have the quartic, that will be my 5. So you should have 5 solutions. Quadratic or quadtwic? Can't even say it. There we go that way. Anyway. Okay. Not a problem, TJ. Thank you for stopping in. I appreciate it. Thank you for the conversation. Because I'm actually going to probably skedaddle myself. And then this was the last one that we did with factoring. All right. So, if you like, maybe, if you liked maybe the format of my book here, this is a book that I actually designed. Okay. It's my ultimate math notebook. It's 100 pages of notes. And then at the same time, and you probably have seen, I have my factor sheet. My factor sheets go from 1 to 200. Okay, just in case some people are not really strong with mathematics, but they need to get to know their factors. And if you notice, what was in red is my perfect prime combination, which we can use for radicals. What's in yellow is your prime numbers. What's in blue is your perfect square roots. And then I also have the rules of integers for you to keep up and just to kind of have a reminder from what should your answer be, positive or negatives. Also, we have the words terminology that's mostly used for most word problems. Then we have our linear equations. Okay, here's that standard form. Here's that standard form as quadratics. We did this one today. All right, we also did the quadratic formula. Then we look at order of operations, exponents. Okay, a little bit of geometry with the transformation of rigid and also dilation. Then we have the properties of quadrilaterals. Then we have a little bit of trig with the Pythagorean theorem, Zogodoa, and most of the identities. I have a couple identities I want to add on to my new book. Then we have the area of sector, which I did I think a couple days ago. Arc length, also did a little stuff with the circle, as well as the unit circle, especially those people that are going into Algebra 2. This will be your new best friend. All right. And then we also have a little bit of brain breaks. Everybody needs one. I know I do. All right. To give you some time to kind of sketch, kind of draw, just to kind of help you refocus all over again. So it's just a nicer way to kind of I know a lot of people say, why the dots? I like the dots because it helps my graphs to look a little bit cleaner. You can take pieces of activity sheets instead of trying to trace it again. You can cut and paste, old time cut and paste. And then the other side is the grid side. So from hardest to easiest, yes. Okay, so it kind of like try to keep everything in line and you can get it all organized. So when there are formulas that you need, boom, you can just go straight to the formula instead of try to figure out what the formula is with the regular notes. Okay, the same thing with the steps. So like here, I had a little bit of what the SOHCAHTOA I did in one of my sessions. I had the formula with the SOHCAHTOA, what it looks like, what it means. And then also I had some of the steps of how to put it in your iPhone. And then also we did a couple other extra problems on the other side. Notice we can do a little bit of graphing. We could do some calculations, take a little bit of Pythagorean theorem over here. All right, and that's what we're going to do next time. And if there's something that your teacher really wants you to keep with your notes, you can tape it into one side and then do a general summarization on the other side. So you can keep everything in here. This is definitely good for almost like, well, regular school year, definitely more than a semester, close to like 3, but definitely will have plenty for those that are taking community college. So if you're interested in it, you can go on Amazon, or you can just click my picture so you can go to my profile. And after you go to my profile, go to my website, and there's a page that will take you directly to the link in Amazon for you to order your own book. Right? So that's all I'm going to be doing for tonight. I may be coming on early tomorrow. Not 5:30 that I wanted to do because I actually have a client at that time. So I'm looking at roughly like around 3:30 tomorrow. So 3:30 to hopefully around 4:30. So I can take a nice little breather to get ready for my session. So if you have any questions, okay? Any questions that I can offer right now or possibly later, go ahead and just message me. I thank you so much for the likes. Oh man, 10K. Awesome. I appreciate that. Noon your time. Yes. I had to think for a second where you're at. Yes. So I'm looking at like around 3 or 3:30, one of the two. Yeah, because I have a nice little gap. Probably 3:30, just to give myself a little breather in between sessions. All right, so anything, and if you're currently taking a class and you want more direct instruction, I do have a study group happening on Mondays. And it is at 8:30 in the morning, 1 p.m. and 8. And there's also a link to that on my website as well. And that's just for my TikTok followers. That's it. I'm not doing it on Facebook. I'm not doing it on Instagram. It's only for my TikTok peeps. All right. So see how much if I can help you guys with that. All right. All right. Well, I'm going to get myself ready to go pass out, so I can get up nice and early in the morning. Hopefully you guys had a good time doing math on a Saturday night. I love you guys. This is awesome. All right. So if you have any questions, do not hesitate to just message me. If you know anyone that is in need for any assistance with math to get them ready for any kind of the tests, ASVAB, ACCUPLACER, where'd my little paper go? I had a little paper. This is what happens when you organize and then you just all of a sudden become disorganized. Anyway, I'll probably find it as soon as we get off the line. That's always the way. You're like, oh, I need to have this and have it ready. Oh, here it is. There we go. Yeah, here we go. So if you know of anyone that needs any private tutoring, okay, anything with the notebook, also help. If you need help with the GED, ASVAB, ACCUPLACER, maybe even Algebra Foundations, you can go to my website, which is on my profile. If you also want to do more support, I would love this. This one is free. Okay? This one, if you can. If you like how I instruct. All right? If you want to, you can do a Google review on me. I appreciate that. And also, the replays of all my lives are on my YouTube channel. So if there is something of interest that you want to, you can go to Audrey Codner, ACG Math Tutoring. Tonight's live, give me a moment because it takes a long time for this to download. Okay, but as soon as it comes up, I'll definitely put it on. All right, so either sometime early tomorrow or like late morning. Okay, so go ahead and subscribe to my YouTube channel. And my next live, like I said, tomorrow, roughly like 3:30. And we might be talking about functions. I'm not sure yet. But we'll see what my earlier students are working on, and whatever they're gapping with, I will share with you. All right. So thank you so much. Thank you for the taps. I love it. It's at like 10.7. That's awesome. I am perfectly fine with that. As long as you guys are getting your questions answered, that is awesome. All right. So have a lovely evening, and I will see you guys sometime mañana. All right. Bye now.